when that buckling failure will be there, before that before load is applying on that column, the length will be total length, but after buckling then there will be effective length. So there are different conditions like this. So here slenderness ratio. What is here slenderness ratio means? Slenderness ratio of a compression member. So column is always a compression member. There is a short column will be there and long columns will be there. So slenderness ratio of a compression member is defined as the ratio of its effective length to least radius of gyration. So here the formula of that slenderness ratio is lambda is equal to effective length by least radius of gyration here. So in problem we'll see this problem, how can we solve with this. So here this is the slenderness ratio. So this is the first problem. First I will see here problem on calculation of slenderness ratio for column. So our question is a steel bar of rectangular section 40 mm into 50 mm. So see here how it will be 40 mm and wait. I will write here given data so you can understand. This is the cross section of the column. So here, what is our given data here? A steel bar of rectangular section 40 mm into 50 mm pinned at each end. So pinned at each end means here the effective length formulas will be there for different conditions. So here pinned at each end is subjected to axial compression. So rectangular section 40 mm into 50 mm. You can see here. This is the breadth is 40 mm and depth is 50 mm here. So here like this x and y by axis here. So you can see here x and y. As per our condition, we have to calculate minimum. So if we are calculating x section and y section, so here a steel bar of rectangular section 40 mm into 50 mm, 40 mm into 50 mm. So here the area is the area is 40 mm into 50 mm. In a given data, area is 40 mm into 50 mm here, area. And what is the cross section here? This is the rectangular cross section. Rectangular cross section. And the bar is 2 meter long. The bar is 2 meter long. So determine the buckling load and the corresponding axial stress using Euler's formula. Euler's formula means that 4 conditions. So already they gave here pinned at each end. Also calculate slenderness ratio if the proportional limit of the material is 200 Newton per mm square here. So here see, you can see here given data, rectangular section area is 40 mm to 50 mm, and here they gave here the proportionality limit here, the material is sigma c means stress is 200 Newton per mm square. See here, stress is 200 Newton per mm square will be there. 200 Newton per mm square. Next, here they gave Young's modulus here, means elasticity of that material. How much they gave in problem? Young's modulus is 2 into 10. This is the basic value for our mile steel also. 2 into 10 to the power 5 Newton per mm square here. 2 into 10 to the power 5 Newton per mm square. So it's the 10 to the power 5 this is the mm square. Mm square. So here we have to calculate. These are the given data for us. Rectangular section and length is 2 meter. So here we have to calculate here stress and at the corresponding of the axial, what is the load is compression subjected to axial compression. And see here our column is like both end of the column are pinned or hinged. So what is the effective length here? The effective length will be same. For this condition, pinned at each end. So pinned at each end means L is equal to L only total. There is effective length means if both side is pinned, so the effective length will be same. So there is no L by 2. If L by 2, L under root by 2, there is a different condition. So the 2 meter, the bar is 2 meter long. So effective length will be 2 meter only. Why? Because here pinned at each end. Whenever the force is applying, here the pin will be there. The up to that pin only, that effective length we have to total, means the bending of that member is exactly at from total length means effective length in this case. So next here, now Euler's crippling buckling load is given by, so this is the formula for us here. This is the formula, pi square e I minimum by L e square means effective length here. So I minimum means here, this is the XX section here. Here XX section will be there. In XX section, they gave already here the cross section of the column. Which one is the XX is and Y by. We have to calculate here moment of inertia. So moment of inertia for given rectangular section about x-axis is given by IXS. So this is the formula for us, BD cube by 12. When it will come to y-axis, then it will be dB cube by 12. So first we'll see BD cube by 12 here. So in given data, if IXX equal to BD cube by 12, BD cube by 12, T is equal to, for us, what is the breadth here? Breadth is 40. 40 into depth is 50 here. Depth is 50. So cube here. BD cube by wait, BD cube by 12. Then the value will become 416.67 into 10 cube